Hello, welcome to Chapter 2, homework questions 63 through 67. Question 63, find the slope of the line containing the points in the table. So if we want to find the slope, we want to find the change of y over the change of x. Since we have multiple points, you can pick any two that you want to be able to find the change of y, the change of x. I'm just going to go ahead and pick this first one, rewrite it as 2, 4. And then just pick the second one here, which is 4, 10. So those are the two I'm going to use, but it doesn't matter which two you use if we're talking about a line. So we'll do the change of y, 4 minus 10, divided by, and I'm taking the y values, and then the x values I'll do 2 minus 4. And so then we get negative 6 divided by negative 2, which we want to simplify to 3. So the slope of the line is 3. And once again, you can choose any 2 points you want to find the slope. Question 64. Use what you know about y equals mx plus b to graph each of the following equations quickly on the same set of axes. So for part A, not sure why we have to do it quickly, but the slope is 3 and the y-intercept is 0, 5. So I'm assuming they want us to do it quickly in the sense that we don't want to use a table. We want to use the two pieces of information given to us. So the y-intercept is at 0, 5, and then the slope is 3. So we'll rise 3 and run 1, or change in y over change in x. So this is 3 and 1. And you can also go in the other direction. You can go down 3 and to the left 1. And the reason that works is because this would be a negative 3 and a negative 1, which is still a positive 3. So we'll get a couple more points on there so I can try to get an accurate line. And once again, make sure you use a straight edge to draw your lines. Since I'm going to have multiple lines on one axis, I'm going to label my line as I go, 3x plus 5. Also change colors. On B, we have a slope of negative 2 with a y-intercept at 0, 10. So 0, 10, and then I'm going to go down 2 and to the right 1. And once again, just get some points on here for me so I can make a nice accurate line since I don't have a straight edge. A little bit off there. Make sure you put arrows on it. And this one we will label as y equals negative 2x plus 10. And then the third one, let's see, we'll do in green. And this one, you don't have a y-intercept, or you do, you just don't see it, it's plus 0. So we have a slope of 1.5 and a y-intercept of 0, 0. Now 1.5, you can easily go 1.5 up and then 1 over. The other thing is you could think about this as a fraction, which would be 3/2, so you could go up 3 and 2 over. Either way will work, so if I go up 1.5 and 1 over, it would be right here. If I go up 3 and 2 over, it's right here. So it still represents the same line. So do that a couple of times, whichever one you're going to use. And then once again, use a straight edge to draw on your line. This line is y equals 1.5x. Question 65. Review what you know about graphs by answering the following questions. A. Find the equation of the line graphed at the right. Well, to find the equation of the line, we need two pieces of information. We need to know what the slope is, and we need to know what the y-intercept is. So the y-intercept, we can see pretty easily here that it looks like it does cross at 1. You can see it has a 2 right here, so that means we're going up by 1s. So the y-intercept is at 0, 1. And then what is the rate of change or the slope? We're going to draw in our slope triangle. That is down 2 and to the right 1, so that means our slope is negative 2, which means we have enough information to write the equation y equals negative 2x plus 1. For part B, what are the x and y-intercepts? Well, we found the y-intercept so that we could write the equation. The x-intercept, maybe not as nice. It's not crossing at one of the lattice points, but it does look like it's halfway in between the 0 and the 1. But also, we know for sure, because we now have our equation, we could plug in to find the x-intercept. We're trying to find the x value when y is 0. We could plug 0 into our equation and solve it and just verify that it is at 1/2. And I'm going to go ahead and do that just to make sure we do have the right x-intercept. And it does look like x is 1/2 So our kind of assumption that it was in between looks like it is correct. Question 66, use the idea of cube roots from problem 1-35 to evaluate the following expressions. Remember cube roots, we're looking for what things multiply themselves 3 times to get whatever, we'll just call it y, to get whatever's inside there. And then that would be your answer, whatever's being multiplied by itself 3 times. So what is the cube root of 1? Well, 1 times 1 times 1 is equal to 1, so the cube root of 1 is 1. On B, what's the cube root of 0? Well, the only way to get 0 when you multiply is to multiply by 0, so the cube root of 0 is 0. What is the cube root of 2 cubed? We could ask the same question and say, what's the cube root of 8, because that's what 2 cubed is, but remember, cube roots and cubes are inverses of each other, so they undo each other. If I do change it to 8, then what is the number that multiplies by itself 3 times to get you 8? And that's 2. So then either way, we're looking at the cube root of 2 cubed, which would be 2. And on the 7, since 7's a little bit larger there, we do want to use the idea of them undoing each other like multiplication and division do. The cube root and the cube cancel each other out and leave you with 7. And the reason that works is because if you multiply the 7 out 3 times, that's your group of 3 that you're looking at in terms of what's being multiplied by itself 3 times. Question 67. Each part, A through D, below represents a different tile pattern. For each one, determine how the pattern is growing and the number of tiles in figure 0. So these all represent different tile patterns. One's given it to you in the tile pattern, one's a graph, one's an equation, and one's a table. They all represent tile patterns, though, so we want to talk about the pattern, how it's growing, so the growth rate, and also the number of tiles in figure 0, which represents that starting value for each of the different representations we have here. So for part A, how much is it growing? Well, we have 2, 4, 6, 8, 10, 12, 13. And then you can see how it's growing on each of these. It looks like we're getting another one here. And then another 2 on top and bottom. And you can double check that, but it does look like we're adding 5 each time. So once again, an extra one here, here, and here. So this would be 23. So it looks like the growth for this one is 5 tiles. And figure 0, if we work our way backwards, figure 1 would be 5 less than that, so that would be 8. Figure 0 would be 5 less than that, which would be 3. So figure 0 has 3 tiles. On part B, we're looking for the initial, or where it's starting. And at figure 0, it looks like it's starting at 3 tiles. And then how is it growing? Well, this one actually is decreasing. So it looks like we go down 2 and to the right 1. And so our growth rate, our growth, is actually decreasing at negative 2 tiles per figure. And then figure 0 is at 3 tiles. Okay, on to C. C is an equation. So what represents the growth? The coefficient of x represents the growth. So we know that on this one, we're growing 3 tiles per figure. Alright, and then where does it start? Where is figure 0, or how many tiles does figure 0 have? Right here, which represents negative 14. Now, negative 14 tiles doesn't really make sense a part of this, but that happens sometimes with tile patterns if you go backwards, that you might not actually have any tiles, and that's okay. But just from the equation alone, it appears there for a tile pattern there would be negative 14 tiles. D, we're looking at a table, and so what we're looking at here is figure 0. Alright, so in figure 0 right here, we have 3 tiles, and then how much is it growing? So here, looks like we are losing 5 tiles every time. And so for each one of these, make sure you're writing the growth and the figure number for the 4 different representations.